All right, so on yesterday we started talking about addition of granules to carbonyls, and we kind of went through the mechanism. Uh, and there's a couple of things that we need to remember and understand about this process. Number one, the carbon of the granule, excuse me, is the nucleophile. Second part that we need to remember is that once that nucleophile attacks the carbonyl, right, is going to form a tetrahedral intermediate, which we talked about here, right? So you attack, it's the carbon of the granule that does the attack. You form a tetrahedral intermediate, and then depending on whether it's an aldehyde or a ketone that you start with, right, you'll have a quench step, which is this third step right here, right? So this is nucleophilic attack. And then tetrahedral intermediate, I'm just gonna then you have your product. All right, so there's a quench step at the end. You add in some weak acid, protonate that oxygen, and you get your alcohol. Again, let's go all the way back. You've been studying synthesis of alkyl halides. Now we're looking at the application of alkyl halides, one of which is to make organometallics. And now we're looking at one of the applications of organometallics was the coupling that we already talked about. Another is here, forming alcohol synthesis using granules to add to carbonyls. All right, so let's go to this example. Somebody help me with this example. I have an ester, and then I have a granule, and they're 1-to-1. What should I get? What should I expect as the product if I add a granule to an ester in a 1-to-1 ratio?
A ketone.
Thank you. A ketone. All right. Do you want to take a stab at what the ketone is going to look like? I mean, we know this part here is not going to change. The question is, what's on the other side of the carbonyl?
Is it the CH3?
It's actually going to be this whole piece right here. Remember, it's the carbon. That's good, though. Thank you. It's the carbon here. That's the nucleophile that's bonded to magnesium. So it's going to be that carbon right here. Right? That makes up that ketone. So it'll be that. Plus, eventually, halogen is bromine. Plus that. Good. Right? Now, what happens if I take that and I add a second mole of granule?
Oh my gosh, I think I remember you saying this. If you add another one, will it be alcohol?
Eventually, yes. So I'm going to add another mole of granule and then quench it. And when I do that, since I'm starting out with a ketone, I should get a tertiary alcohol. Right, so whatever is attached to that granule, whatever is bonded to the metal, excuse me, is that carbon that's going to be your nucleophile. So when you react here, it's going to be this carbon that I have highlighted in blue that's going to attack the ester, right? So we can, even if we went through the mechanism, we could draw an arrow coming from here to here, like so. Still, we will still get to this tetrahedral intermediate that looks like this. Right, and then you have here OCH3, and then wait a minute. Right, that's what the intermediate would look like. Right, and then from that intermediate, that's going to collapse or decompose. And that's how we end up with that product. The first product, if you notice, is, let me move this up. It's the ketone plus that. Right, and if I take that ketone and react it with another mole of Grignard, I'm going to get alcohol. All right, questions about that? I really hate that I didn't send out this retrosynthesis video, but that's okay. We're going to jump in. Yeah, actually, let's work through some of these problems down here, and then we'll come back and jump into that retrosynthesis. So let me move this page up. All right, we're not worried about the mechanism. We're just predicting the products. All right, so what that in that first example, if you'll notice how it's written, in the first step, I'm adding my Grignard. Second step is my quench, right? It's my H plus step where I'm adding a proton. All right. So looking at the Grignard, two questions. Number one, which carbon in the Grignard is going to attack the ketone? Number two, what does the product look like? Anybody?
When the CH, would it be the CH3 that attacks the
Okay. All right, let's think about it. Which of those two carbons is more negative? Because again, a Grignard is a nucleophile, right? It's going to act as a nucleophile, a lover of nuclei. It's going to donate electrons. So if we wrote that Grignard out, right, this carbon right here, excuse me, doesn't have any electrons to give, right? It's this carbon that's bonded to magnesium that has partial negative charge, and then magnesium is partially positive. So it's going to be this carbon right here that attacks. right? It's the granular is, if it's acting as a nucleophile, and you also have to remember this, that the carbonyl is polarized too. So this carbon is partially positive, oxygen partially negative. So knowing that, that helps to guide us. All of these reactions are going to be, if it's not a radical reaction, it's some nucleophile, electrophile interaction. So going back to part one, if you understand what a nucleophile is, what an electrophile is, and how they interact, then it makes this a little easier to grasp, right? So the CH3 is not nucleophilic, but the CH2 is. So the product over here is going to look like this, right? This doesn't change. None of that reacts. It's going to be an alcohol. And here, right? It's that CH2 carbon that's going to attack. Is that clear?
Yeah.
Okay. All right. Let's do the next one. First of all, that second example, is that a ketone or aldehyde?
Is it aldehyde?
It's a ketone. And aldehyde would have a hydrogen on one of those, on either side of the carbonyl, either on the left or on the right. One of those groups will be a hydrogen. But since this is both carbon groups, then it's a ketone. All right, so knowing that, what type of alcohol can I expect from this in the product? If I start with an aldehyde, I get a specific type of alcohol. If I start with a ketone, I get a specific type of alcohol. If I start with an ester, then I get, depending on the stoichiometry, that's depending on the stoichiometry. But what type of alcohol can I expect from a ketone reacting with a green?
Did you say the quaternary or something like that? Tertiary
Yes,
alcohol?
it's a tertiary alcohol. You're gonna, just like the top one, that's a ketone also, and you get a tertiary alcohol. I didn't, well, I screwed that up. That should be, and nobody caught that. That should be a CH3. Or maybe you caught it and just didn't say anything. All right, so let's go back and ask this question again. In the Grignard, which carbon is going to attack the carbonyl?
You said the less negative one.
More negative one.
I'm so sorry. I'm getting mixed up.
That's all right. That's okay. That's okay. The more negative. So which carbon is the most negative out of all the carbons in the chain? Then let's ask. Right. If any, let me solve that mystery. If you have a Grignard, the carbon that's going to react without question, you don't even have to look anywhere past where the metal is bonded. The carbon that the metal is bonded to here is going to be your nucleophile every time, every single time. So you don't have to, like, don't second guess which carbon is. I'm only asking that question to reinforce the point, right? The carbon that reacts is the carbon that's bonded to the metal. All right. So if we were to put in an arrow here and here, even though it's just said predict the products, but I think at this point we need to actually see. So this is a salt now, and then carbon on there, and then here. Right. So once that attacks, you get the intermediate here, and then in the second step, you add in H plus. That's what the acetic acid is for. Let me ask this question to see who would, if you've been paying attention. What if I added the acetic acid first and then added the Gruyere? What would happen? So what happens to a Gruyere when I put it around an acidic proton? Anybody?
When it change it, because I don't know how though, but when it changed the outcome of what you get.
Would it react with the Gruyere if I just put the acid and the Gruyere together? Are they going to react?
I'm not sure. I don't think so.
Here, right? Anytime you have a Gruyere, the one thing you want to avoid prior to reacting that Gruyere with your substrate that you're trying to react it with is protons, right? You never want to have protons around the Gruyere. So if I add the acid first, the Gruyere is just going to react with that and not the ketone, right? So you want to keep that Gruyere away from any proton sources because it'll just react with the proton source and be done, right? Once you protonate that carbon, in this case, it will be this carbon right here. You can see over here, it's a CH4. Once you add that proton, that Gruyere is done and there's nothing you can do about it. It's a wrap. So the order of addition matters. That's the point I'm trying to make, right? So if I add in H+, I'm going to get this alcohol, OH, like that, right? These two groups remain the same. Those two groups there don't change. All right. And again, when you see the reaction written like this, that means you're doing it in steps. So the best way to explain that is I'll set up the ester in whatever solvent I'm using, ether or whatever aprotic solvent. I syringe that in. I syringe in my Gruyere using you have to actually use what's called a cold finger, like a really specialized device for that. But that's beside the point. You add that, you go to lunch, and then you come back and you do your quench step, depending on how long the reaction has to run. If it's a 2-hour reaction, then you go to lunch, come back, read a couple of publications, check on some other stuff, and then boom, you're ready to quench it. If it's a 24-hour reaction, set it up before you go home from the lab, and then come back in the morning and quench it. Either way, when you see a reaction written in steps like this with a 1 and a 2 like that, that means that you're doing the first step first, and then that intermediate product that you get from that step, you're going to quench it with it in the second step. So somebody help me with this problem right here. What's the ratio of Gruyere to ester?
Is it 2-to-1?
It's a 2-to-1 ratio. Good. What does that mean? If I'm adding 2 moles of a Gruyere to an ester, what does that mean?
You will get an alcohol.
Yes, I'm going to get out of alcohol, not a ketone, right? I'll only get a ketone from that ester if I add in 1 mole, if the ratio is 1-to-1. What would the alcohol look like? This doesn't change. Right? What?
We'll have the part that isn't, I guess, attached to the middle.
You said is or isn't?
Isn't. Well, is. I guess everything that's not attached to that's attached to the middle will just go to that carbon right there.
Right here?
Yeah. And then you'll have the halogen in the middle.
Mm-hmm. And that group. All of that is going to be a salt with magnesium. Another way to think about this, if you get confused about, especially if it's written out like this in kind of in Lewis or in condensed form like that, is if I attached at the CH3, let me just draw it. I'm gonna erase this, so don't worry about. If I attached here, what's the problem with this carbon right here? This is another way to think about this. if I'm reacting with a granular like this one, and I have a CH3 and a CH2, this is another way to think about this. What's the problem with that carbon? If I attach through the CH3, what's the problem with that carbon?
You can't attach anywhere because it has all the
Got too many. It has too many bonds.
Yes, too many bonds. Yeah.
Right over here, if it's a CH3, that means it's got 4 bonds, right? Which is carbon can only form 4 bonds. So if I attach from that end, that means that CH3 is now going to have 5 bonds to it, and that's not good. That'll never happen. Right. So that's just another way to think about it, to keep from second guessing. Right. It's always the carbon that's bonded to the metal that's going to attack. All right. Let's go through this sequence down here, these 2 sequences, and then we're going to start on the retrosynthesis. We'll go back up to another example. What is the outcome of that first reaction? Where I take an aryl halide and stir it with magnesium at 0 degrees in ether. What's the outcome of that reaction? And what am I doing? What does that reaction accomplish?
Oh wow. I didn't write that down in my notes, I think, because I remember watching the video about this, the 0 degrees and the significance, but I think I forgot.
All right, that's actually the first thing that we learned about organometallics is how to make them. You take an alkyl halide or an aryl halide or a vinyl halide and react it with magnesium. Now the temperature is different. The temperature says 0. When we first learned this, it was -78. All right, but that first reaction is actually how you make granules, right? You take the aryl halide, stir it with magnesium, low temperature, and aprotic solvent, and you should get a granule that looks like this. All right, now in the second step of that sequence, what am I doing? I have a granule. First step, which is indicated by the number 1 over the arrow, is to add in aldehyde. And the second step is to add in some HCl. What am I doing there?
You turn into an alkane.
If you're reacting a granule with an aldehyde or a ketone, what do we get from that? And then quench it at the end. What do we get from that?
Oh, I think I'm looking at the wrong thing. An alcohol
an alcohol.
Yeah.
Okay, so what carbon in the granule is going to attack the carbonyl carbon, right? It's going to attack right here at the carbonyl. Which carbon in the granule is going to do that?
The one attached to the middle.
Yes. This one. Right? So in the alcohol, in the product, I'm going to see this here. So this will still be here. That doesn't react. So this is OH. That's after the quench. And then my hydrogen is here. And then my ring is here. Notice it's the whole ring. Now it's not just one carbon out of the ring, or yeah, it's the whole thing. Everything is bonded together on the left side, so I got to keep it intact on the right side. What type of alcohol is that? Is it primary? Is it secondary? Is it tertiary?
Is it tertiary?
Okay, let's back up. How can I predict if I'm going to get a secondary or tertiary? There's a way to predict that. Based on the carbonyl, there's a way to predict it. Wouldn't it, then we talk about this Wednesday. If you have a aldehyde, you'll get a secondary. If you have a ketone, you're going to get a tertiary. So this starting material is which of those two? Is it an aldehyde or a ketone?
This you said is an aldehyde because it
An
has.
aldehyde. Yes.
It's not an aldehyde. Okay.
Yes,
Oh.
it is. No, you're good. You're good. So it's aldehyde. So that means I'm going to get a secondary alcohol. What that means in theory is that the central carbon, or the carbon where the alcohol is going to have two carbons attached to it. That's all that means. But if you start with an aldehyde, then you're going to get a secondary alcohol. Start with a ketone, you're going to get a tertiary. All right. Let's do the last example, but I need somebody to do it. I'm not doing it. So somebody else can explain to me what's happening in the first step and the second step and in the third step. Help me out.